Now that we've looked at reference, let's paint out some of these areas that we want the flame values to appear. Right now we're just scattering points with this pyro source, but there's a much better way of doing that. So let's give ourselves some room down here, and I'm going to use a node called the Attributes Paint node. And this node is new to Houdini 18. It basically makes it a lot faster and easier to paint out attributes. So, as you might imagine, we want to go to our attributes and specify the attribute name as flame. If we set the visibility here, as you can see, we now have our logs, but in order to activate this node in our viewport, we need to press this little multi-handle button right here. So as soon as we press that, now we have the ability to see this attribute. Let's go here and turn off lighting. And as you can see, now we're able to paint this. And actually, I'll go right here with this headlight so that we still can see the logs, but now we can just paint out where these flames are at. So if you just click and drag, that will paint this out. Middle mouse will erase. What I've generally found works pretty well is if you hold down Shift and right mouse, that'll give us a small brush size, and we can just paint out little areas like this. And I'm leaving some areas that are not affected by the flames at all. Because as you saw in the reference, it's not like we just have huge areas that represent one body of flame. They're really kind of broken up into these tiny little sections like this. And that's where the flames come from. Now again, everything is generally happening towards the middle. So it makes sense to paint these areas more intensely, like that. And as you paint, you want to go back and forth between positive values, so painting like positive like this, and then erasing them. So you can kind of see me doing that as I go along. I'm adding values like this, and then I'm taking away. And I'm going back and forth like that. And by doing so, it just usually gives you a better looking shape by the end of it, or a better looking result by the end of it. It's something that you'll commonly see with sculpting workflows as well. So anyway, like I said, you don't want to add too much of this. We don't want to do this sort of thing, right? So I'm just starting with these areas that are facing towards the center. And actually at the center, let's go ahead and just add a bunch right there. And also remember that this is just where flames are allowed to be and where they're not. It's not the same thing as drawing out intensity of the flames. That'll be something different. We just want to space this out and provide some areas where this is happening, not happening, and then we'll do some additional breakup with the noise as well. So anyway, I'm going to paint this out as you've seen me do. Go ahead and do the same. I'll pause this video, and then when I'm done, you'll see the final results. All right, and there we go. Now, obviously, we might need to go back and change this and repaint this. It's just going to get us started in a general direction, but notice how I just have all of these small little patches where flames are allowed to happen. And I've tried to avoid big old stretches like this so that we have these small bodies of flame that all emit from the log, and then as they go upwards, they'll combine together to give us bigger bodies of flame. So there we go. Now that we have that, let's set that to our pyro source. And after the attribute paint, we now want to scatter based on this attribute. So let's create a scatter node right here. We'll say density attributes, flame, right there. And now this will serve as our points. Let's try 20,000 and see what that does. So there we go. 20,000 isn't too bad. Let's go down to the bottom and also turn off this relax iterations. That'll cause a less uniform distribution of those points. And usually I like this because it just looks a little bit more random. Okay, so now at the pyro source, we need to say mode, keep input, right there. And everything should apply as usual. Now let's just double check what we have here. I think the particle scale needs to be turned down. Let's try 0.25. And probably go up from there a tad bit, so maybe 0.4. There we go. On the rasterize, let's take our voxel size to 0.005. So we'll double that resolution. Now we're at 500,000 voxels, which isn't too bad. But let's just maybe take our coverage scale to 10.0075. And then again on this Pyro source, let's go back up here. It's always a process of going back and forth. So 0.5 in that particle scale. Now we're around 300,000. I want just a tad bit more resolution though. So let's take our voxel size down to what it was before, which is 0.005. And I think this might serve our needs pretty well. Let's also go up to the Pyro source, turn down this particle scale, again, just a little bit, 0.35, and I think this is what we're generally after. Back to these noises, let's bypass a small noise real fast and focus on the large noise again. On the distribution, again, we want something that's either 0 or 1, like that. And let's take this pulse duration up, so we'll say 2 on that, so that our noise does not move as quickly. And let's actually turn that up even more, let's say 5. Perhaps the large noise will represent flames gradually disappearing and coming to being. Again, generally flames stick to the same area, and they do shut off, so to speak, but it happens at a slow rate. So let's try a pulse duration of 4, element size. Let's try going down just a tad bit on that, so 0.5. And we'll have to do a flipbook to double check that, but I think this will work out just fine. Now on the small noise, let's do a very similar thing. We will have a faster pulse duration on this, so instead of 4, let's try maybe 1.5 and see what that does. I think this might be a good idea right here. And now that we have all that, let's try doing a flipbook with this volume visualization and see what this looks like when we're going 30 frames per second. So I'll do 150 frames and we'll see what that looks like. So here we go, we have this, and the one thing that I'll probably change is on the large noise. I want to make that move just a tad bit faster. And besides that, my recommendation is to not get too nitpicky at this point. We're probably going to go back and change all this stuff anyway, so you just want to get it in a general area that's improved from where it was before. So we have that, and let's now go to our large noise. I'll just say pulse duration of 3. And then before we get to this flames out, it's also a decent idea to make a file cache for this Pyro source. You don't really have to do this, but I think it's not a bad idea usually. So I'll just say Pyro source $os $f4.bgo.sc. There we go. Okay, great. So now we have this. We're right around, I believe, 300,000 voxels. Well, we're at 487, so that's fine. As long as it's not 3 million, 5 million. I mean, you can go that high, but this will make a very big impact on how long your simulation takes. And so the lower you can get away with these voxel values, usually the better. We don't want to lose too much information, but we want just the minimum to capture the areas that we want. Okay, awesome. So now that we have that, we've improved our source a little bit. Let's go back to the PyroSim and improve what we have going on in here. With this new source, here's what we have. So as you can see, we start off in these little sections, and as they get taller, they start combining into bigger licks of flame. Kind of like I was saying. So even though we painted out those small areas, it still allows us to have bigger bodies of flame. It just happens when it rises to a certain point. And that's good. The next thing that I do is I would specify the domain. Now, the idea here is that with the sparse Pyro solver, this thing is able to go as far as it wants, right? In other words, I can have a simulation where I'm way out here and this VDB volume is allowed to go all the way across like this, and it's not contained by anything. Now, in many situations, this is ideal, and this is why sparse pyrosolver is really cool, especially for missile trails and things like that. But in this case, we do want to limit this domain so that we're not thinking about voxels that won't show up in our shot anyway. It'll just speed things up, and we don't want to have things being calculated in areas that the camera doesn't see. So that's what this max size here is going to do for us. If you check the max size and we check on domain, this represents the areas that will get cut off whenever this goes to simulate. So the max size in X, let's say maybe that's 5, or less than that, 3, maybe even less than that, 2.5. I think that should be about good. The Y, let's try 5 on that as well. Maybe 6, actually. We'll go 6. And then with Z, we'll try 2.5 as well. This is another great reason why it's important to bring whatever you're simulating to the origin, because it makes these settings really convenient as well. Now, this is also different than this treat X, Y, and Z, because this acts as a boundary that the volumes are allowed to collide with. So, for instance, if I had a ground plane and I wanted the fire to bounce off the ground plane, I could say treat Y as closed above, like that, and as you can see, it'll clip off anything above 0. Or I could say closed below, it goes the opposite direction. And the difference, again, between this and the max size is that this will collide with the volumes, whereas this max size will not. So now at this point, we have a few different options. We could start thinking about microsolvers, we could start sourcing in other volumes, or we can start setting up a shader and a rendering setup so that we have a general idea of what this looks like. I prefer setting up a shader at this point, so we'll do that in the next video. I'll talk about how to shade fire, and then once we have that set up, we'll correlate that with what we see in the smoke object, and we'll have some sort of preview that we can use to judge all the other microsolvers and sourcing effects as we go along.